Is everybody awake? Or it's already lunchtime? All right, this is an important topic, and the reason it's important is that most projects in this era fail. What that means, what does fail mean? Fail doesn't mean you didn't build the project. Fail doesn't mean you didn't submit the code. Fail doesn't mean that you didn't go to your boss and tell her that you're done with the project. Fail means there was no revenue from that project. The company didn't make any profit or mitigate any loss. That's what fail means. And this is not me, this is Gartner. We are all excited about AI/ML. There are investments in AI/ML. However, what is happening is we are solving it as an intellectual problem rather than a company profit or loss problem. This is what I hear most of the times when we go or firms come to us or firms come to us for training their employees. This is what I hear. Where should I start? I already have a data science team, but when I give them a complex project, they can't do it. Can you upskill us? How do I develop an AI research mindset within the organization? We are fighting with every other team. The data science team is fighting with the business team. The business is fighting with the IT. Nobody is speaking to each other, so we don't get success. So this is what I hear from CEOs, CXOs, VPs in many, many organizations in India. So how do you go from 85% failure to 100% success? Now, solutions are available, but there is a general mindset of solving all problems with one God. All right? One data scientist hired, one PhD hired can somehow by magic solve everything without planning, without thinking, without talking to teams. So, first, guidance. And I say guidance because we've done this for about 25 years, and we've got people who continue to struggle with companies on this path. Identify business problems that can be solved with AI/ML. Not all can. Not all problems are worthy of solving with AI/ML. You can use common sense, you can use rules, you can use processes and solve them. Do a gain by pain analysis. What is that? We recently were with a company and I was having a workshop and they said, I said, tell me if you were to solve this problem through AI/ML, what is the profit you will make or what is the loss you will mitigate? It's been 2-3 months, we are still struggling with that answer because we have not attached AI initiatives to profit or loss. And these are senior executives, people. They are not small. They are not 8-level experienced managers. They are VPs and CEOs of companies. So we've started this data science journey, but 1 project, 2 projects, some automations is where we seem to be stuck. Analyze all the problems that you have that you want to solve through AI/ML. Pick the ones which have the highest gain and lowest pain. Pain means what? The data is in varying systems and just extracting the data will take me 3 months. The data is there, but it's so unclean that I've got to go and get a team to clean it, and that will take time. Or worse, I still need to collect this data, I haven't collected it. So that is pain. It's real pain. It will. If you choose a project with that kind of pain, it's going to take you a year and it will be abandoned. So do a gain. By gain, it's ROI. You have to be able to compute in rupee terms what doing that AI/ML project will mean in rupee terms. Now, many people tell me, ma'am, I've got like 4 years of experience. I don't understand the business. Then the business shouldn't be telling you to do that project because 2 months later, the business will say, we've hired these hotshot data scientists and we are not making any progress. So ask the questions. What is the gain? It can't be, I will save the job of 2 people. And many times I get this answer from consulting firms. We finished a project and we are trying to present to the CEO, CDO, or CAO, and they say, can you help us with the computation of gain? This is after the project has ended. And then we are struggling to help, and We come out with people saying, I'll save 10 people's jobs. Okay? 10 into what? 8 lakh, 10 lakh? Is that the reason? The cost of the 3 months of that project has far exceeded that, those 10 people's jobs. So it can't be about 10 people's jobs. All right? So pick, and there is a way to do this, the pain-gain analysis. Pick problems that have high gain and low pain for the first ones. When you see success, you can go on to other problems. Create a roadmap. If you have 20 problems, and this could be across departments, if you have 20 problems to solve the first 5, then move forward. Usually companies pick believe me, this is funny when I say it on stage, the most complex problems to solve through AI/ML, where the complexity has nothing to do with AI/ML solving it. So be clear, this is the start. Without this start, you can jump in, but you will come back to this in a year's time, and much money, skills, people will be wasted. Plan, plan, plan. And I mean with pen and paper. Not with coding, not with hiring, pen, paper. That means anybody initiating an AI/ML roadmap or journey has to sit down and put a business hat, has to sit down and put an engineer's hat, and has to put a data scientist hat. What does that mean? Business hat, some examples. What's the impact? ROI. If you don't know the ROI, you shouldn't be starting that project. Is it for research? Even research has an ROI. You want to file a patent or a publication. Compute it. It takes a little while, but you'll get a number where you look at the number and say, wow, or you look at the number and say, this should be the last project I do. There are many projects that can be solved far more elegantly with simple Excel sheets. They don't require AI/ML. So that's the business hat. The other aspect of the business hat. Am I currently solving this problem already? Do I want to go in and solve it better? Or do I currently have nothing in place? So if you have currently nothing in place, a simple algorithm will work. If you have something in place that has unstructured data, a lot of complex data, then you will need a data scientist with very heavy lifting skills to solve the same problem. Don't take a PhD and make them solve a simple AI/ML problem, not required. So this is your business thinking. This doesn't come after hiring that PhD. And the PhD will exit because you're making them solve some small problems. So that's the business hat. What's a domain hat? Okay, and many people tell me this, but I have a data architect. Why are you asking me to think like this? Because you have to tell the data architect whether you have unstructured data or structured data. If it's unstructured data, they might need high-level computing. They might need more servers. If you don't bank for that early on, after the project is done and you are feeling like, okay, I'm going to get promoted, you realize you have to wait 6 months for a server acquisition. So that's the business hat. The data part is also your role. Engineer's hat. What is an engineering hat? What are the skills I need before I start the project? Can my data scientist become an engineer to put a model into production? Believe me, he or she can't. Most data scientists are trained to build algorithms. They are not ML DevOps engineers. They are two different lines. So you have to hire before. Otherwise, your model will stay in a deck and in code, and it won't get put into production. You need that team skilling up front or thinking what they will need. Will I do things real online or will I do them offline? These are all the questions you need to ask much before a project starts, not while it starts, not in the middle. Skilling. It's the most talked about thing at this conference, skilling. The gentleman before me talked about skilling. I'll tell you where the problem with skilling is. We hire one data scientist and they are supposed to do ML DevOps, data architecture, algorithm building, business insights, automation, everything, because I hired one data scientist. They can't. So get specific about skills. Which skills? What is missing in that skills? View the whole process. Who starts? Who will extract the data? Do you have a data architect in the pipeline who can extract the data? Or can your data science team extract that data by themselves? Who will clean the data? If the new data scientist has no domain knowledge, which business person is going to sit with them to clean the data? I remember a conversation on skilling where someone said, the people who come into the system don't know how to do feature engineering. It's another word for a variable creation. Feature engineering is a domain issue. If you're new in the company and know nothing about the business, it doesn't matter what business, you can't feature engineer. Yes, you can take a date column, put a date in. You can take simple columns, age column, transaction column, and put it in. But you can't feature engineer. For that, you need domain knowledge. Expecting a fresher in the company to have domain knowledge is putting too much burden on that person. All right? So skills are specific. What do you need? If you need a data scientist to build algorithms, have that data scientist build algorithms or do business insights or whatever else. You need ML DevOps, you need some other people, you need a business smart domain person who's been in the system. Get specific about skilling. Go to companies who are very clear on technical skills. Don't build resumes that have everything. Say, I want algorithms and these type of algorithms. Say, I want someone to put this in production systems and hire that someone. Don't try to save money by saying one person can do everything. They can't, you'll fail. And we say this because we get people every day who are failing. And we have to kind of help them and support them. Applied skills. I teach master's students, I teach doctoral students, I teach certificate students, so I teach across the board. Applied knowledge. Have they been in a hackathon? Have they got problems in real life that they can solve? Can they recognize that business is about profit and loss, and then comes the predictive part of the algorithm? So look at companies, look at talent people who are specific with applied skills. It's not enough to do a master's program unless it's very applied, or a doctoral program, and come out to your job and start running. So, you could probably hire 3 less people if you paid attention to the exact skills. When I see resumes and this conversation about feature engineering, the reason it made me laugh is when I see resumes, there are 4 paragraphs on the type of algorithms that that person needs to work on. There is not a single line about domain knowledge of feature engineering. That's a given. No, it's not a given. Remember your first job, you didn't know anything about the business. It took you minimum 2 to 3 years to learn. So you can't expect a fresher to have my experience. It's unfair. So be specific about skilling. Invest in doctoral candidates for complex problem solving, patents, publications, filing. Many people within organizations do this. There are many, many intrinsically motivated data scientists who do file patents, who do that. But it's a personal effort they make, and it's long and tedious. So hire your doctoral candidates, sponsor doctoral candidates among smart candidates, and give them complex problems. There are companies that support this over a 3-year, 4-year PhD program that can help you solve your complex problems, give you the publication and give you the patent, and you will be able to scale that organization faster. What I usually see, a PhD is hired and we put freshers under him, which is great, but you're underutilizing the PhD on simple problems. So make that balance. It's extremely important. And the problems are becoming more complex. In fact, data science teams need to be hired for only complex problem solving. The rest of the company has to become data literate and start solving regular problems. What used to be PhD problems 10 years ago are now solved in 3rd year of bachelor programs in AI&ML. That's how fast things have moved. So let your whole company become data literate. Even an Excel can build a simple regression model. Okay, what else do you need to look at? Your data strategy. What that means is how much data, what type of data. 10 years ago, we just had RDBMS databases. Today, most data is unstructured data. Unstructured data requires different kind of thinking in terms of investment. Performance metrics. This is something I can tell you 100 wonderful stories on. We consult with companies where senior people tell us, this should be what the model should give us. This should be the accuracy. This should be the technical metric. Most of them are not technical, but they are defining for their data science teams the technical metric that the model should get out. What they are not defining is the business metric and the engineering constraint. I think all of you know that example of Netflix. Years ago now, Netflix took out a $1 million prize for somebody who will beat their recommendation engine by whatever amount. All the mathematicians in the world were excited because such a competition with a $1 million prize had never been heard of. So people formed teams and attacked the problem. There were smart teams, many teams came close. One team, I think, beat the algorithm by some 0.00, some ridiculous small amount. But okay, they beat the algorithm. They submitted their algorithm to Netflix. Netflix paid them the money. They went home. Netflix never used the algorithm. Can someone tell me why? Go ahead. Complex, but what happened due to that complexity? Correct, you are right. Maybe it was not? Okay, no, not necessary. Okay, you are close. Okay, he's close. Okay, somebody else. No. So, the technical metrics were fine. They beat the technical metrics. The engineers at Netflix came back and said, when this algorithm is so complex that when it pops, remember, you see movies and you see recommendations down, it takes too long. And Netflix definition of too long could be like 3 seconds. But they have internal benchmarks. It takes too long to pop up the recommendation. And they didn't use it. Because what had not been done is the engineering metric had not been put ahead, that you build the algorithm, you get the price, but the serving of the algorithm needs to be within so many seconds. And we will test that, and only then we will give you the price. That constraint was never put forth with the mathematical teams. And this is what usually happens in businesses. Businesses define the technical metrics, and it's funny, for the data science team. But they forget to define the business metric and the engineering constraint for the team. So I have a huge line of data scientists in my talks who say, ma'am, they are asking for a precision of 40%, they are asking for 60%, and I tell them, what is the precision today? And they say 0. You can't jump from 0 to 60. This is not magic. And they're crying, these people, ma'am, what will I do? How will I do? And there are no business metrics defined. I'll tell you another story. Reviews. We had to build an algorithm for reviews, and we had to separate the good reviews from the bad reviews. Not a bad, meaning a decent exercise to do. And then those good reviews were supposed to automatically go onto the client's brand website and kind of play out there. So we did everything. The model was fine. And when we were doing error analysis, meaning what that means in layman terms is which reviews the algorithm was not able to catch. The bad ones were said as good and the good ones as bad. We realized many people were writing positive reviews but with swear words. With huge swear words. So we went back to the analytics officer and said, are you okay with a good review going on your brand website with some nice choice swear words in it? He said, what are you saying to me? Of course not. Okay. But when you told me the business problem, you said good reviews and bad reviews. You never said that you had a business constraint that said no good reviews with unpardonable language. That's a business constraint. So when you look at performance metrics, think about, and many of you who lead data science teams, who are 8-year or 10-year, who are guiding data science teams, think about the business and the engineering metrics. Let the data science tell you what the technical metric will come out to be. So what we end up doing is we are kind of bounding the technical team without really knowing about the technical metrics, but unbounding them for the metrics we are supposed to dictate to them. All right, so this is extremely important. Performance metrics can't be decided after the algorithm is done. So technical metrics, business metrics, and engineering metrics. I thought a lot before I came to present this because we have a whole class on some of the stories that I'm telling here. And there's a reason for the classes. We encounter these issues when companies start adopting their digital transformation. So some of the issues you see here have come up again and again. So Dr. Murthy, who's a founder, we all sat down and said we need to have like a module or a course that instructs students to start thinking like this. So this is not just coming from one story. This is coming from so many businesses coming and telling us the technical metric should be this. Okay, do you have a current model? Yes. Okay, can you show me the current model? Oh, somebody was just doing some experimentation. Then how did you get 60? I don't know. This is very real. So you define the performance metrics for your teams when they start, and be reasonable. The other challenge, productionization. Most times people don't have enough talent. The biggest demand in data science right now is ML DevOps engineers. Not the ones who want to write the algorithm. Actually, algorithms are very easy to write these days. It's the ones who pick that model and put it into production systems and make it work so that the business earns money. The greatest demand and the scarcity is for people who have that technical skill. So think about productionization in terms of infrastructure, talent, and people who have done this before. If you have to poach people from other companies who've done it before, poach, because these are not skills that are learned in a day. They're hard skills. Make sure human issues don't derail. What are human issues? What are human issues? Anybody? Adoption of AI/ML. What do you think are the human issues that derail that adoption? Sorry? Very good. Fear, ego. One more. Fear, ego. Passive-aggressive resistance to change. If you will not break that down and have a plan for it right before the project starts, you will not win. Most AI projects fail long-term because of human issues. And by human issues, I don't mean you didn't hire a data scientist. It's the resistance to change. I'll lose my job. It's a real fear. People think AI/ML is going to take away all our jobs. Maybe 20 years from now, but we'll have new roles. So they will not get involved, and especially if it comes to their business unit. Oh, I can do it better. What will the machine tell me? But these are leaders. If leaders do not adopt it, there is no way people under them will adopt it. So it's important. Now, if you believe that you can circumvent that in any way, so education for your people on how their roles will change, that they will, the way we say it is, we are here to take away all your dirty tasks. You will do something better. They will. But you've got to do that talking, that walking, and that communication very early on. There's another story I can tell. Built a nice system, put it into production, went to the client and said, you just have to press 4 buttons and everything will be done. The team that was taking the system said, left it with them, 1 month passed, 2 months passed, nobody was doing anything. So the leader came and said, nothing is happening. What, did you build a complex system? No, it's very simple. You put a handbook, put written, put nice screens. Another 2 months passed, nothing happening. Went and talked to the team. Then what's happening? This is too complex. I will have to waste 4 minutes doing this and that. All right? How would you like to do it? So they gave us some design. Spent another 3 months, changed the design. Again went back, nobody's using it. Again went to the team. Oh, this is still too complex. Now I just want one button. Okay, never mind how. Now the project is bleeding. There's loss taking place. Never mind how, we got one button. Simplified, dumbed it down, one button. Now we went. Now now we expected like miraculous results. Now people will press one button and everything will happen. The leader came to us and said, they are saying their process is so complex. How can one button be the answer? So guess what we did? That original solution, after 1 year of delay, went back again. These are real cases. What is happening here? People have not taken them along. They have not been told, you will do some better tasks. Let these tasks go to a machine or decision support or whatever. So we wasted 1 year in coming back to the solution that was first delivered because nobody had spoken to the teams. Nobody had removed fear, ego, and inertia. Those 3 things can completely kill your AI adoption for the long term. The other issue, human issues. This is now the people who plan the proof of concepts. What do you think you should pick up as a project for a proof of concept? Simple project, complex project, what areas do you think should be picked up as a POC? Anyone? Proof of concept that will finally turn into a full project. There may be many ideas. Okay. Usually what happens, the projects picked up for POCs are the ones that are the easiest projects. By easiest, I mean data science easy. The complex parts are data extraction, other issues, process issues, it will go and get stuck. POC should be done in the areas which are complex from a process, data, and productionization. If you clean up that pipeline, the data science is easy. Most people think that the complex algorithm is the hero in the POC. And then they get stuck because some process doesn't move, you don't have enough data, data is lying in some other system, or productionization for some reasons is stalled. The POC needs to be one of those 3 things, not the algorithm. So that's one way to look at the problem. Last but not the least, knowledge management. Where is your model? Can I take a look at your model? Oh, ma'am, the person who was building it left the company. Okay? Is there a documentation? Yes, I'll get it. The documentation comes, there's an Excel sheet with some numbers in it. Pay attention, you have spent time, years, effort. It can be a simple template, but this has to be hammered in technology workers that documentation for a model in the system needs to be there. You cannot release a person from the project without that. Because people leave, things move, guess what happens? So when people like me are called in, we have to rebuild from scratch. You pay us more money for knowledge management not being there in your system. This, as you build complex models, it will really be in that person's head. So you'll be calling him when he's in the 3rd company and saying, what did you do? That is usually the way, by the way, it's done. Can you tell me what you did 3 years ago? Somebody else is attacking the problem. Now, I know not all companies are like this, but in AI/ML, all companies are like this. So that's the last piece. I have 46 seconds. I hope I have shown you some ways to move forward in your AI adoption journey. I will take any questions that you have.